Hello, Aditi. Hello, Veda.
Good evening, sir.
Good evening. Okay, बच्चा लोग. Today we'll start fluid, mechanical properties of fluid.
So your voice is breaking. You were saying something?
Yeah, we'll start today mechanical properties of fluid.
Okay, sir.
Sir, you're starting new chapter now.
Yeah,
Okay.
new chapter in the sense is it's related to first chapter only, previous chapter only.
Okay, sir.
That was solid. This is fluid. Let me just share my page. Okay, so we saw mechanical properties of solid. In that, what are things we saw? Can you just give me brief of the chapter?
Stress and strain, young
Stress, strain,
models,
yes, modulus, elasticity, plasticity, bulk modulus, all those modulus. Yes. So in that, what we saw, how much it can bend, how much it can, like how much we bend it, so it will be not be breaking. At what point it will be breaking. This whole thing we saw. But same thing, it can't be applied on liquid. We cannot break liquid. So what we can do to liquid? They will relate it to your same way as what we did for solids. We bend
Sir,
it, we
change
broke
in
it.
pressure?
Yes,
Like,
we can change the pressure, or we can change pressure.
sir, heating and cooling them?
Yes, applying temperatures. Anything else? Can we change area of that object, and with that we can change pressure again? So generally here we will do that. We are going to change the pressure only. Mostly we will go around pressure. Pressure, then density. What else? Yeah, what those things we'll see that. Yeah, even viscosity also. Yes, pressure, density, viscosity, volume, temperature. So those are things we can see that. Now, what are types of pressure that liquid or fluid can observe? Can you hear me, right? I got logged out. Was I audible?
Oh, yeah, sir, can you repeat the question?
Okay, yeah. I forgot what was I asking? Yeah, about pressure. What are types of pressure we can see? We know. What are pressure like? What are types of pressure you know?
Sir, absolute pressure, gauge pressure,
Gauge
atmospheric pressure,
pressure. Yes, gauge pressure, atmospheric pressure,
partial pressure.
hydro. Yeah, and hydraulic pressure. Okay. So let's start with here fluid pressure. Fluid pressure. So fluid pressure in the sense like same way. How the pressure works? Same way. Force by area. So now here, what type of force?
Force exerted by the walls of the container or the
Container. Yes.
atmosphere.
Or atmosphere. Yes. Wherever the fluid is present. So let's take force exerted normally at a unit area of that surface of fluid. Surface. So same way, pressure equals to force by area, dimension or unit. What's the unit of pressure? Anyone? What's the unit of pressure?
Pascal,
Pascal or
Bar.
bar,
what?
Newton per meter square.
Newton per meter square. Something else also somebody said.
sir,
Yes.
bar,
Yeah. Okay. So these are the units for pressure. So generally we will use this one. Do you know conversion of Pascal to bar?
1 bar is equals to 10 to
Yes, correct.
the power
So
of
1 bar equals 10 to power 5.
5.
Okay, fine. So if we know units, then can we know dimension also? What are dimension of this pressure? M, L, T. Quickly tell me. Dimension. M1, L1, T1. Right? Is this right?
No, sir.
Then what is the correct one?
Sir, it is M ln was T minus 2.
T minus 2. L1.
L
T minus
inverse.
2. What did you say? L?
Is it L inverse?
Okay, L
Because
inverse.
area is in the denominator, right?
Yeah. So now it is correct. So M1 L1 T minus 2 divided by L2, it will become M1 L minus 1 T minus 2. Force by area. Okay. Now, whenever we are studying about fluid, one thing is here Newton will not come, here Pascal will come. Pascal's law. these laws, whatever it is, it's all are almost similar. So it says that pressure in a fluid which is in equilibrium is equals to or same as everywhere. It will be same. So we are neglecting gravity. So pressure throughout that surface, like it means what any liquid is in some container, it will be same throughout everywhere. Okay, so if you want to change the pressure, we need to change area. So there we'll see. Okay, so like pressure in a fluid, it will be in equilibrium everywhere. Or it's the same throughout, provided we are neglecting this gravity part. Or other way of saying this one, let's say this, any excess pressure. Which is applied on a mass. Applied anywhere in a mass of or incompressible fluid. So same excess pressure applied anywhere in the mass for incompressible fluid, this will be transmitted throughout in all direction. Without reducing its own value or whatever. Same, meaning is same. So let's see application. In short, overall pressure will be equal. First one, hydraulic. Lift. So do you know hydraulic lift? Okay. So here, what are we doing? We are applying a force here or here. Either way, wherever, like whatever it is requirement according to that. So let's see first. Force equals to pressure into area. So here, chota force equals to pressure into chota area. Here we will take small area, area A. Here, area capital A. So pressure which is transmitted from bigger area to the smaller area, it is not diminished. Okay. From like a smaller container to larger container. So it is not diminished. It is just compressed and moved away. So same way, this is the principle based is based on our like Pascal's law only. Same. That's why it is called application of Pascal's law. So the piston, which you can see in this red colors, those are pistons. Okay, in the smaller area and bigger area. So which is exerting force, which is a force is applied here. We are applying a force, Chota force on F side, that is F Chota force. So here pressure is transmitted from the smaller pipe to the bigger area, larger cylinder.
So we can
So
see
that
the pressure at a point will be equal at both the point, like both the areas, and then we
not
can like
yeah,
then we can use it to find force, right?
we can use it to find like how much pressure is transmitted. See here, what I mean to say here, this if I find out force by area and this force by area will be equal. That is what my thing is, because pressure around this one is same. Overall pressure is same here.
That's what I said. Like if we take
Yeah,
both the pressure on the both the areas are same, we can find the
same.
equation.
Yes. Equals to Chota and Chota area. So if you want to find force on this side, so we can use this Chota force on Chota area and Bada area. Or whatever way, as per the question requires. So in short, overall pressure is same. Pressure is what? Ratio between force and area. So you can make a note of it, write in your own words, whatever. Same goes for hydraulic brakes. This is hydraulic lift. We are lifting something up. So hydraulic brakes also work same way.
They're like lifting heavier objects.
Exactly. With a smaller force applied. Shall we go next?
Yes, sir.
Chalo. Or hydrostatic and so first thing comes here, high atmospheric pressure. This thing you're studying in 10th standard also. What is atmospheric pressure?
The pressure of the Earth atmosphere.
Pressure of the atmosphere. Okay. Yes, yes.
Like normal pressure, like atmosphere pressure at sea level.
Yeah. Or yeah, related to sea level. Correct. So pressure which is around our atmosphere. Even like whatever pressure we have, we are standing here near our hand, whatever pressure we are feeling, we won't feel because we are habitual to that. Because we are from Earth only. So if someone comes out of the Earth who are staying in like space station, not just, I'm not talking about aliens, but whoever staying in space station, so they will feel different right now because they are habitual to that. Whenever they comes after 6 months, they are kept under observation because they are not habitual. Since 6 months, they are not habitual to another thing. Because our human body get adapted from 21 days. Like it's like calculated science something. 21 days to 3 months. So it will take 21 days to adapt to whatever atmosphere they are in. That's why, like you might have seen in YouTube or Instagram, like a 21 days challenge and like so many days like that. It is what it's about, like human psychology. So that is not my point here, but here atmospheric pressure, like it is different whenever we are feeling. We won't feel because we are habitual to that. So whenever this people comes from the space station, ISS, so they will be staying for like some 21 days minimum to come out like of that thing, and slowly they will start adapting because they have stayed in some different atmosphere. So let's start with this each thing, and hydrostatic and same gauge on all that. It's simple only. Let's start with first atmospheric. So what shall we write here? Exerted around like a Earth atmosphere. Let's write simple words. Exert pressure on Earth's atmosphere. So at sea level, it values goes like 1.0125. So let's round off to 1.01 into 10 to the power 5 Pascal. Next, let's go for Mr. Hydrostatic pressure. No, hydrostatic pressure. Name itself we can understand. Hydrostatic. Static means steady condition. Hydro means liquid or water or whatever. Let's take it as water. So where can water be steady? Here, water everywhere flowing in pond or something like that. So whenever we go deep inside, so there water will be almost steady condition. So pressure around that so let's say here pressure at a depth h below the surface. So P equals to H rho G. Now P is your pressure, H is the height, rho is the density of that fluid, and G is acceleration due to gravity. Now here next is your gauge pressure. So this is what P naught plus H rho G. So what it says that pressure in this, which is equal to sum of what? This is atmospheric. Acting on surface, and from here hydrostatic. So P minus P naught equals to H rho G. So make a note of it. All three types of pressure you can write in your own words, whatever it is. Then
Sir, over.
over. Others?
Yes, sir, done.
Chalo, super. Then we'll go for next. So next is your buoyancy Archimedes principle. Now, have you heard of this buoyancy? Almost everyone has played with water, obviously. So when you're dipping your some bucket or something, whatever. So even your hand also, whenever you're keeping your hand on water, so you will feel pressure. You'll feel someone is pushing upward, not like air. In air, like we can do easily. So there is a pressure or force that is buoyant force, which is giving you upthrust. Upthrust means upward force. That is a buoyant force. This was given by Mr. Archimedes. This is all story about him. Same thing. He was like sitting in that, you know, all the stories, right? He was sitting in somewhere and he found like, okay, these people are like, yeah, same like Newton. Okay, then let's see here buoyancy. So if we go with words, it's very easy. Like whenever like some liquid, we are placing some, it's full here, suppose, and we are placing some tumbler here, and we are pressing inside. So how much force it can go inside, how much force we are applying, that much force will be up thrust here. It will be measured by the liquid out, moving out. It will be like measured by moving out. So how much force applied here, it will be equal, same force up, it will be moving upward, same with the same force that fluid will apply. That is a buoyant force. So if a body partially or wholly immersed in a fluid, it experience upward force due to which is fluid surrounding it. So this phenomena is called buoyancy, and force which is applied, it is called buoyant force, simple, or upthrust. Now here I gave example of like liquid, okay, but it can be same for air. This is the reason airplanes are flying. From here only we got idea, okay, airplanes are flying this way. If you observe your airplane, okay, I hope this looks like airplane. Okay, so this wings, if you observe that wings, they are doing this upthrust part. Even fuselage also made of same way. This fuselage also made a aerodynamic shape. We'll study that in later of this chapter. This is the most important chapter for you're studying any of the aeronautical engineering like this, like me. So this one, like if you observe, this airplane is made up of like made as a fuselage only, like same aerofoil shape. That is okay. That is not my point right now. So, yeah. In this one, there are some flags, flaps here. So this can go up and down as per the requirement. So this will make a complete whenever like they are taking off, and whenever we want brake. So most brakes applies on takeoff and landing. The remaining part is just gliding. If you know gliding, right? Like gliding means just flying over. So whenever they are taking off, these flaps are moved up, and whenever take down, it will be moved. So up and down movement. So this is what a buoyancy works here. So up thrust, so force which is making them to push up. So they are taking a force. So it will be like if we take this balance here, it will be push down. So this will take up here. This will take this position so that we can start take off easy way. So this was, they started in the first like Wright brothers, they started this way. They use this buoyancy principle, which was given by Mr. Archimedes. Okay, so up thrust, that's what I have showed you here. Up thrust means how much fluid in the sense here air, how much they are inside it experience of force which is moving upward now. That is called up thrust. This phenomena is called buoyant. See, and force which is giving them up thrust, which is pushing them up, that is called Y-A-N-T, buoyant force. Okay, don't mind my spelling, I might be wrong, but okay. You or up thrust. So this is the force which decide that your boat is going to go up or about to be sink. So this is the force which is this is going to decide your tumbler, which is you're applying of pressure on the top, which is going to sink or still it is going to like float. Same way, which is the force. This is the force which will decide like airplane will fly or it will go down. Now, in that, there are so many factors acting on it. First thing we will see that is weight. Weight means under force under gravity. So main thing here it will act, that is force under gravity. Now, whenever the object is in the, let's say, submarine, so obviously it is under high pressure. Now, gravitational force also acting on it. So obviously it will start sinking. So they have to apply so much force to make it like at some proper level, some whatever, I don't know, maybe 800 meters. I'm not sure about it, but yeah, they are around 800 to 1000 meters submarines. Not much. Okay, so this is the force which decide all these things. Is it going to sink? Is it going to float? Is it going to fly? It's going to drop. That is the reason this is most important topic for like not as per the JEE mains exam, but if you're going for some engineering and all that, there you will study like fluid mechanics as a big subject. Yeah, we are just studying little properties. There you will have some depth. But actually it is interesting too. Okay, let's go with this principle. Okay, principle no need to write here, same thing. Whenever we are about to say in your, like, I don't know you have exam for this one or not, but generally we won't have for JEE exams. But we need to know just buoyancy. Okay, yeah, that's it. Who gave this principle? Mr. Archimedes. So its principles goes like this, like whenever body is partially or wholly immersed in a fluid. Now here comes the important part, that is weight are balanced. Let's write like this here. When a body is immersed, whatever way it is, partially or wholly or totally or whatever, in a fluid, it appears to lose a part of its weight. See, it is appearing, it's not losing actually. And apparent loss of weight is equals to weight of fluid which is displaced, which is moved. So apparent loss of weight is equals to weight of a fluid displaced. This is what Mr. Archimedes described. As we discuss here also, same thing. Now, how we will decide that this object is about to sink or object is about to float? I'll just give you one here, then you have to tell me. This is the whatever bucket. This is something floating or whatever. So this force which is applied, let's draw here. This force is W dash, which is upthrust force. And W is your whatever fluid having, weight of the body or whatever. So now tell me what condition it might be, which should be greater than body should be sinking. I want body sink, body will float. Which condition it will be? When body can be sinking, when body can be floating? Tell me. Yes? Tell me. When body will sink and when body will float? Guys, are you there? Are you listening?
The body will float when the mass of the body is more than the buoyancy of the liquid.
Means upward force, means downward force is greater than upward force. That's what you
Yes,
mean.
sir. The body will float is the opposite of that.
Okay, so you mean W is greater than W dash.
Yes, sir.
That's okay. What about others? She said this way. Okay. Shirisha, what do you think?
Same, sir.
It will be floating or sinking?
It is sinking, I think so.
Sinking. Okay. Aditi, any other condition? Akshit, what about you? What do you have to say? Akshit? When body will float and when body will sink? Akshit, tell me. No answer. Chalo, theek hai. When W is greater than W dash, so body will sink because Yeah, because as she said, yes, correct. It will be heavier. Object will be heavier. When float, when W is equals to W dash, it will be floating. Not necessarily whole, it will go like some part also it might be floating, or some part of that object will be like this. Some part will be floating, or this is also condition. Not a little part will be floating, like without touching. Just, I mean, not touching, without like inside the water. Without the some volume will be inside the water. This is also condition of floating. This is also condition of floating. Both are floating. Okay. So if you want to make a note of it, write in your own words or whatever, make a note of it. Next class will be most important for this chapter, that is streamlined object. Done? Writing part done?
Yes, sir.
Okay. Okay, guys. Then see you tomorrow.